Okay, so do you hear me properly? All right. My name is Hamed. Do you see like here? Okay. So number one. So I'm happy that I'm here. Last year I was the tutor of this course. This year I will be again the TA of this course. My name is Hamed. I'm not sure if you have seen me in other courses. So this is my name. I finished my PhD from this university from mathematics, not engineering. So I might teach a little bit differently rather than the other tutors. So I will do my best. Teaching of the probability is traditionally hard, okay? But I have lectured like the similar courses at this university and TA for this course. So I will use my experience, knowledge, and I will try to deliver the notions in a best way. Okay, so, it seems that you see, so do you see the materials properly? Okay. Yes? Okay. All right. So the first week, the first week of tutorials, but we are in the week 2. It's a little bit okay. We will be able to finish without having any trouble. But you should take everything serious, okay? Because the assignment will not be easy, okay? But this course is very applicable to like in your future jobs. Okay, so it's today's topics. Today's topic will be about the fundamental of the mathematics of probability. So we see that we have a truss. And it depends on three like dock or whatever we call it, A, B, C, whatever they are. So you see this, okay? So we got A, B, C. If any of them fail, then the whole truss will be like in trouble, okay? A, B, C, okay? So I'm a little bit not happy with the screen. So what I can do is this. Better. So this is better a little bit, yeah? All right. So we got the A, B, C, okay? The first question, you will see that it's about inclusion and exclusion principle, or the addition rule. The addition rule, which you have studied in the second lecture. So what's the second lecture? So it will be like about this. Okay. So this one, the figure is called Venn diagram. E1 union with E2, and we will have What E1 and E2? I'm pretty sure that you know that it's E1 intersection with E2. Okay, so this E1 and E2, just the third expression. The third expression is E1 intersection with E2. Okay, for some reason in this course we don't write it. All right, back to the question. So the failing of any of the dock A, B, C, respectively, it's written for us 500, 500, 500s, 400s, 300s, respectively. The failure of any of them, as I said, it will consist of it will cause the failure of the whole truss. Okay. So the question says, assume that the failure of the individual members is statistically independent. Well, it's yes, somehow it's a little bit understandable. So one of the this basis of this test, like it fails the basis, the other one is like independent from the other one. So it says that what's the probability of the failure of the truss? Okay, failure of the truss. As I said, the failure of the one of them, any of them, or two of them, or all of them, or means union, and means intersection in the mathematics of logic. So the logic you might see in the electrical engineering as well. So a failure of any of them means A in union with B, union with C. Okay, back to the question. The probability of the whole truss means probability of the A union with B, union with C. Okay. Yeah. So now the probability of the statistically independent will simplify everything. So using the addition rule, or in some context, or in Wikipedia, it's called inclusion and exclusion principle. So probability of A plus probability of B plus C minus intersection of two of them plus intersection of three plus intersection of all of that. So how can we prove this one? By using the two of them, E1 union with E2. If we start with plus single of them minus intersection of both of the choosing any arbitrary both of them plus choosing any arbitrary three of them. Yes, if you have four, you will just proceed like this. Okay, plus minus 4 plus minus plus minus. Okay, so it's okay now. Probability of A, B, C, we got them. We can just substitute them. Minus probability of A, B, probability of A, C, probability of B, C. Okay, what we will use is because they are separate, independent, not separate, because they are independent. So probability of A intersection with B means probability of A times probability of B. And the reason is coming from conditional probability. Okay, we will review. So I have written highlighted orange color, probability of AB equal to probability of multiplication of probability of A and probability of B. So I will rewrite any of these, probability of AB probability of AB, probability of AB. Probability of, no, the third for the last expression, probability of multiplication of probability, any probability of any of them. Okay, so can I ask you please? So we got the information 500s, 4 and 300s. Okay, can you tell me what the answer is, please, someone? What's the answer? Okay, I heard something. Someone said something. Okay, so do you have question about this question? Zero point what? No. Uh-huh. 3, 6, excellent. Thank you very much. Okay, so I have written here in another language. I see the answer, but I just wanted to activate you. All right. Okay, so do you have question about there are a couple of questions that you can ask from this question, but I want like is there any question about this? Okay, so why did I write this one? Okay, this question, why did I write? So it's just simple formula here. Probability of trust. I just I just wrote this one. Okay, it's okay. But the problem is that if we don't know that it is independent, they are independent, but it will be hard. So how I was able to write this one? Any answer for this? Statistically independent. Okay. Okay, so let's assume that probability of A condition B. Okay, I can write probability of A intersection B divided by what? Divided by what? This one, what should I write here? A conditional probability. Okay, year 10 mathematics. Okay, probability of B. So this means probability of this A, but I restricted my world to the B. Okay, So let's assume that this A doesn't depend on B. So the answer of this one is probability of A. Therefore, so you will have probability of A equal to A intersection with B or AB. Probability of B. From here, probability of AB is equal to probability of A, probability of B. Because we assume that here, probability of A, since A is not in the condition of B, so the probability of this conditional probability is just probability of A. Therefore, I am able to write this probability of intersection or this one, AB, as this. Okay. Any question up to now? Okay. So let's analyze the alternative way to obtain this question. All right. So the alternative way is coming from this law. So if you have the number of the set, math 1110, the number of set is equal to A complement. Okay, so whole, let's assume that whole, not one, actually n. Okay, so the probability version of this one is equal to probability of A equal to 1 minus probability of A complement, or so sometimes we write this one as A bar. Okay, so assume that we want to obtain this one, A union with B union with C. Okay, so this is equal to 1 minus probability of A union with B union with C, everything complements. Okay, now I can use this law. Do you see this one here? A union with B complement is equal to A complement intersection B complement. Have you seen this one? Have you heard about De Morgan's law? So we got this De Morgan's law, okay? So therefore, you can write for the triplet as well. So A, B, C complements with A bar intersection B bar intersection with C bar. Let's come here. So therefore, here A union with B union with C, it is possible for me to write probability of A bar times or intersection B bar intersection with C bar. Okay, you will use these things in your first assignment, definitely. Okay, so a rule, a remark. The remark is this: if you have AB, the probability of AB, we were able to write multiplication of the probability of any of them. Okay, if AB, they are statistically independent, therefore we can conclude that their complement are also statistically independent. As a result, probability of A bar B bar is equal to probability of A bar times probability of B bar. So what we can use, so what's the usage of this one is here. So therefore I can write this triplet here probability of A bar, B bar, C bar is equal to probability of A bar times probability of B bar times probability of C bar. Okay, so this remark as well is important. So from here, 1 minus probability of A bar, probability of B bar, probability of C bar. Probability of A bar is just this single probability of A bar is equal 1 minus probability of A. This probability of B bar is equal to the probability of this highlighted A bar is equal to this one. So the others as well follow the same rule. So what we then just to do is just substitution, and we will get definitely same answer. Okay, do you have question about this? This course is not easier than Math 2310 or 1120. Okay, so you should take this course serious from the first tutorials, and I strongly recommend to look for the other extra examples if you find. Or okay, so do you have question about this one? Okay. Question 2. So there's engineering company, and they are trying to build a prototype drone. Okay, so they are analyzing the like failing this drone in 2 aspects. One of them is malfunction of the in the power part or power malfunction, and the second reason that this drone can fail, it will be because of a mechanical problem, like in the motor, in the blades, and other parts of the drone. So 2 aspects: power malfunction, and the second reason can cause this drone fail is because of the mechanical damages of any part of the drones. So the question, their experience, the company's experience gave us some information about the failing of the drone. They analyzed, and according to their experience, the first part says that, let's assume that the event that we will have power malfunction, we will call it A. It's here. We will call it A. And the other part, the second reason, we will call it B. Okay, B is here. Oh, actually it's written. Okay, and according to the company's experience, the probability that drone will fail because of the first reason is twice of the second reason. So the probability of the A will be equal to twice of probability of the second reason. Now, I talked about the first item. The second item is this. It says that the probability of the failing of the drone from power malfunction, the probability that malfunction will happen provided that there was a mechanical engineering problem as well It means probability of the malfunction provided that mechanical problem will happened. Okay, so conditional probability of A, condition B will be this one. Okay, so I talked about this one. So this company has this confidence that they claim that the probability of the failure of the drone is 1,000, 1/1000. Okay, I don't know it's good or not good. So let's go to the first part. It says that calculates the probability of the power malfunction. Okay, it says that give me the probability of A. In simple math language says, what's the probability of A? Okay, always the inclusion and exclusion principle is the first one that can help. So I write the probability of A union with B, or probability of F here, which is equal to probability of A plus probability of ENGG2100. Probability of each of them minus probability of their intersection. So this one. So what was this one? From this probability of A union with B, or probability of F, is 1/1000. So I will write this one. Probability of A, I don't know. We want to find it. Probability of B, okay, I don't write anything. Minus probability of A intersection with B, AB. So what I did here, just nothing. I just substituted probability of A union with B, so which is 1,000, equal to probability of A plus probability of B. Instead of probability of AB, I wrote this one. Why? Where does this come from? So where does this come from? The last pink highlight. What is this? Where did I get this? Why I was able to write probability of AB as this. Any suggestion for this? So do you remember conditional probability definition? So I have written actually here. Okay, that's fine. Probability of AB is equal to probability of conditional probability times probability of B. So that's why I have written this one. All right, so again, this one is equal. Probability of A is the variable. It means unknown one. I write this one. Probability of B, already we know that it is half of the first reason. Okay, probability of the mechanical problem is half of probability of the power of malfunction. Okay, so I write this one. Probability of A condition B instead of probability of B, I write this one. Probability A divided by 2. So probability A condition with B. Okay. So can someone help me about this? Okay, so I write this one here, and I write this first and second expression as 3/2 minus probability of A, I write here from here. Probability of this, actually, I wrote this one to here. Probability A condition with B was 8/10. So it was 8/10. With this 2 here. With this 2 and 8/10, I wrote this 4/10. Okay, so can you please tell me that what's the probability of A? You've got some calculator, maybe. Zero, 0, 0, 9. Okay, 9. What's the probability of B? Probability of B? How did you know that? Okay, yes. Okay. So how did I write probability of B? Where did I get that? Probability of B, probability of the mechanical problem. As I said, probability of mechanical problem, according to the condition of the question, it's half of the probability of the power malfunction. As a result, what I get for probability of A, I will halve it and I will write it, assign it to the probability of B. All right. So is there any question about part A? Any question about this? Three over 2? Yeah, this one. Probability of A plus half of probability of A, 1.5. Yeah. Any other question? All right. Second, okay. So the second part, I'm talking about the yellow highlighted part. So we are going to solve this question. If the drone fails, what's the probability that only power malfunction has occurred? So it says only power malfunction. It means there was no mechanical engineering. What's the mechanical malfunction? I'm keeping saying like mechanical engineering. Actually, it's mechanical malfunction. Okay, so we are going to solve that probability of if the drone failed already, okay, it will be in the condition. This part. the probability of F. F is happened, the drone failed. So we want to find probability of the probability that only power malfunction happened. Okay, only means probability of A, power malfunction, intersection with no issue about the mechanical parts. B, bar, or B, complements. Provided that we had the failure of the drone. So what I follow is just relying on the principles, the original definitions, and here conditional probability is the definition of this probability. So probability of this one, this is equal to probability of A, this part, intersection with F. So AB bar intersection with F divided by probability of F. Only the definition of the conditional probability. Okay, so here is equal to probability of AB bar divided by probability of F. Okay? So why I was able to write this one? See the numerator, probability of AB bar F. F disappeared suddenly. Why? Beg your pardon, please allow. But I kept probability of F for the denominator. F is the A union with B. Any idea about this? Okay, so here is A, here is B. Let's keep like, let's do this like this. Oh. So the green part is for probability of the power malfunction, and the probability of the mechanical part is B. They are they got like intersection as well, but whole of this is equal to F. So if A intersection with B bar, intersection with bigger, like union of these, then is this intersection? No. This is equal with A union, A intersection with B bar. In another, let's give another example. Here is the X big set, and here is the A. Okay, what's the A intersection with X? What's the intersection of A and X? A. Do you understand? Did you get the idea? Okay. All right, so for the same reason, AB bar is like, here is the A, and here is the B bar again. Actually this part. So that's why it's the subset of F. So the intersection can be eliminated. The intersection of F can be eliminated. All right. So now probability of A, B bar. We can write this one, probability of A minus probability of A intersection with B, divided by same denominator. Again, why? So you will see these things in, I'm not sure if the tutorial solutions will be available. However, if they are available, I doubt if you like completely get the ideas line by line. Okay. So now the question is that how I able to write probability of AB bar as this probability of A minus probability of AB? Do you have any idea about this? Okay, the answer is like I have prepared for you here on the left. Okay, so look at this one. You see the probability A, B bar. It means A intersection with B complement. Okay, so A is given here. B complement will be this part. Every orange color and which is outside of B. Now, if I have A intersection with B, it will be just inside A, outside of B. So that's why this highlighted by blue is probability of A, B bar. But from this Venn diagram, I'm able to write probability of A minus probability of A intersection with B. Probability of whole of this minus probability of this little thing. Since they are separate, I am able to write this equation, this subtraction. Okay, you are welcome to take a photo or just like draw it. Okay. So now probability of A, I'm writing this one here, probability of AB, okay? Probability of A intersection with B only is the definition of the conditional probability. Okay, so this yellow part comes here, just the definition of the conditional probability, and I sub it here. Okay. I've got the probability of A from the previous question. It is 0.0091, 90 or 91 minus probability of A. Probability of the A condition with B is just 8/10 times probability of B. We had that from the previous question. 0.3045. It's here. Probability of F. It's given by the question. Okay, so let's keep writing. What's the answer of this one, by the way? So I see the answer, but I want you to calculate. What's the answer? Pardon? Oh, no, sorry. . So in your assignment, you should have you should be able to calculate very carefully, because you will have these questions like there might be your answer might be close to the original right solution, but it will be multiple choice, multiple choice questions. So you should be careful. Okay, I'm still waiting for your answer for this question. Any idea? Beg your pardon? 0.546. Okay. Close. 5.5. Okay, but thank you for your effort. All right. So, but the calculation, we assume that you can do your calculation with the calculators very quickly and fast. That will be your skill. However, the notions, understanding the notions are also part of the course. If you have any question, please let me know. Yes, please. I opted, so in because the answer was 0.009, that's 91. But we obtained here, we wrote 90, but it's okay. It's very fine. Any other question, please? Any question? Okay, so let's go to the this question. So this question says that we have 3 villages, okay, and so here A, B, C, and the flooding, they are alongside of a river, and flooding one of them might cause the flooding the other one. Okay. So you see that C is on the top. Maybe it is CBA. So the water comes from this side, from the top to the down, and we see that definitely probability of this upper village or city of get flooded is less. If this city flooded, then the probability of this second city will be more. But independently, probability of this village, maybe because it's in the path in the path of the water, the river, so the probability is higher. The probability of this last city is 2/10. I'm not sure why. Why this should be less than B? For some reasons, we don't know. So the measurement can be can happen because of the experience of the 10 years, 20 years, it depends on these things. So as I said, they are not statistically independent, because definitely if C get the village C get flooded, then the second city will be flooded as well. So the probability will be higher, at least. Now, you see that the probability of any of these cities alone, it's written here. It's 2/10 here, 3/10 here, and 1/10. All right. Now, they are not independent, as I said. One thing, if all of the cities are flooded, we will call that year disaster year. Okay, I'm sorry. So if all of them are flooded. Now, we have some conditional probability. If the town C is flooded in a given year, okay, then probability that second city will be flooded is written here, 6/10. So let's assume that C is flooded. Okay, then probability of the flooding for the second city will be higher, not 3/10, it will be twice. So 6/10 here. Now, the probability if both B and C, village C and village B, if both of these cities are flooded, then the probability of the last city get flooded will be so high, 8/10. It's too much. Okay, yellow highlighted, and yellow highlighted is here. Okay, I have so English writing here, and here mathematics language. Probability of last city provided that both cities B and C happened. So it will be 8/10. All right. However, if the town C is not flooded, okay, the probability that both cities A and B will be fine is 9/10. So we should take care of village C. Okay, it should be in the priority. Now, what's the probability of a given year is a disaster? Okay, the disaster, what was the definition of the disaster? It's all of the cities are flooded. It means A happened and B happened and C happened and, not or. And means intersection, okay? So probability of A intersection with B intersection C. So in your assignments, in your mid-semester exam, will you have? I'm not sure. In your exam, if you see and, it means intersection. If you see that there in the question there is or this, it means union. So probability of A and B and C is equal to just because I have some information about the conditional probability, so I just use the conditional probability definition. Probability of A condition with BC times probability of BC. Why I chose BC? Because I see that BC is written here. Probability of A condition with BC, probability of BC. Probability of A, BC, yellow part is given here. Probability of probability of BC. Again, I will use conditional probability. Probability B condition C times probability of C. So probability of B intersection C is equal, actually, probability of B condition C is equal to probability C. So I used this one. I used this little one, so I wrote this one. Okay, so the purple one is given here, 6/10. Yellow part is given here. Probability of C is definitely given to us. So I will be needing your help again. So yellow part is 8/10 times probability of B condition C is 6/10. Probability of C is given to us. It's here. 1/10. So what's the question without calculator? Yeah. Do you have question about this? Any question about this part? Okay, so now let's do second part. If the town B is flooded in a given year, okay, what's the probability of town C is also flooded? So it means obviously B happened. We want to measure the probability of happening of the flood for village C. So probability of C condition B. So probability of C condition B is equal to probability of C intersection with B divided by probability of B. This is equal to probability BC divided by B. Probability of B intersection C is definitely probability of is equal to probability of C intersection with B. So now this part, probability of BC, I can write from here, probability of this BC, B condition C times C. So probability of B condition C times probability of C divided by whatever it is, whatever in denominator. So now, can I get your help? Okay. 6/10 times probability of C is the easy one, 1/10. Probability of B, what's that? 3/10. Okay. What's the answer? Yes, thank you. Okay, so we finished the questions. Okay. I will be happy if you have more questions. If you have question about the lecture notes, please let me know. Question 1, 2, 3 is finished for today. Yes, there's nothing. Do you want me to go some pages and you want to, if you missed writing something? And if you please, if you have feedback for me about my teaching, please let me know, or please just tell to Dr. Jin Song Wang, okay? No, you are welcome. I'm still staying here. If you have question, if you want to ask anything privately, just come and see me.